For your warm-up, it says a right triangle has leg lengths A and B and hypotenuse C. Find the unknown side length. We're going to use the Pythagorean theorem and replace the values with the information provided. So A is 4. We are looking for B, and C is 6. 4 squared is 16. 6 squared is 36. So to solve it for B, we have to subtract 16 from both sides. That leaves us with B squared equals 20. The way that we undo a square is by using what's called a square root. So this would leave us with B equals the square root of 20. Complete the remaining problems to finish up your warm-up. In your workbook, problem 1 says, consider the line. Draw a right triangle with vertical and horizontal legs so that its hypotenuse is on the line. So we have vertical and horizontal legs. And you have a point here in the corner of the box, and then a point here. Find the value of the height to base ratio of your triangle. Well, the height here is 1, 2, 3, 4. It goes from 5 to 9, so that's a height of 4. And the base went from 2 to 5, so 1, 2, 3. And 4/3 is already in its simplified format. You could change it to a mixed number, but you do not have to. So here you can see that height of 4 and the base of 3. If you use different points on that same line, you could have the height to base ratio, which was 12 to 9, but those are both multiples of 3. So if I divide the top by 3 and the bottom by 3, that also results in a value of the ratio as 4/3. So it does not matter which 2 points you use on the line. In its reduced format, the value of the ratio will remain the same. Looking at this diagram, we can determine that these two triangles, the blue and the red, are similar using AA criterion. The first angle that they have in common is this angle here. And then they also both have a right angle. So by AA criterion, these triangles are the same, or similar. If I were to adjust this, are these triangles still similar? What if I do something like this? Yes, because these are on the same line segment, or on the same line, we can still say that these two angles are identical. So by AA criterion, these two triangles are similar. Even if we make it larger, we can see specifically that this line here could be considered a transversal of these. So these are corresponding angles. You could also state that these two angles are corresponding. So they have 3 angles that are the same. In your book, problem 2 says, consider triangle ABC and triangle JKL. What is the relationship between triangle ABC and triangle JKL? Explain. Well, they have vertical and horizontal legs that fall on the same line. So by a criterion, they are similar. B, what is the length of JK? Because these are similar, the ratio between the triangles will remain the same. So here, these two will have the same ratio as these two. So we have 8 over 24 is the same as 5 over our unknown JK. You can put a variable there. You could use JK. And the way that we solve this type of relationship is using cross multiplication. So 8 times JK would be 8JK. And then this side, 24 times 5 is 120. To solve it for JK, we have to divide both sides by 8. That leaves us with the side JK, and then 120 divided by 8 will tell us its side length, which is 15 units. In the diagram, one side in one of the triangles is mislabeled. Which side is mislabeled? How do you know? Well, let's look at the height to base ratio. I'll try and keep them color coordinated. So in this one, the height is 45 and the base is 30. Both of those have multiples of 15. 15 fits into 45 3 times and into 30 twice. How about this triangle? This height is 15 and its base is 10. Those are both multiples of 5. 5 times 3 makes 15, and 5 times 2 makes 10. So far, those both match. How about this green one? The height is 12, and the base is 8. 12 and 8 are both multiples of 4. 4 times 3 is 12, and 4 times 2 is 8. That still matches. In this orange one, we have a height of 10 and a base of 5. Those are both multiples of 5. 5 fits into 10 twice and into 5 one time. So this is the only one that does not match the height to base ratio. So now let's determine which side we think is incorrect. If I take this piece here, that appears to be half of 10, but this does not appear to be 2/3 of 15. So we're going to say that 10 is the incorrect side length because the 5 looks correct. It looks to be about half of that 10. Oops. I'm just going to move that out of the way. it is the only triangle that does not have the ratio 3:2. Well, then what is the correct length of the side you identified in part A? So now we need to correct it. If we're saying that 5 is correct, what is the correct distance here? And we want it to be in the ratio 3:2. I'm going to use a variable for that mystery side length. We cross multiply 3 times 5 and x times 2. To solve for x, I have to divide the 2 out. That leaves me with x. And 15 divided by 2 is 7.5. So the correct side length is 7.5 units. What do you know about the value of A to B? And how do you know? Well, they're both on the same line. So we know that the angles in this triangle have to match the angles in this triangle because it's that vertical and horizontal leg based on that 90-degree angle. So we know they are similar. So the ratio of A over B has to be equal to, well, A is the vertical side length, so we need the vertical side length here. B is the horizontal, so it has to match with the horizontal there. And we can reduce that. 33 and 44 are both multiples of 11. So 11 times 3 is 33, and 11 times 4 is 44. So we know that the ratio of the side lengths here has to match 3/4. We also know that A is going to be greater than 33, and B is going to be greater than 44 because it is longer. Look at this diagram. How are these triangles different from the triangles we have been working with? Well, these hypotenuses are not on the same line. They are not the same line. So we can't say for certain that these are similar. And just by appearance, we would say they are not similar. But they may not be drawn to scale. So we would need more information. We only have one angle to compare because they're not on the same line. We cannot claim AA criterion. And that is all for this lesson. Check back in the playlist for more videos.